Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer quiz 3 questions. So altogether, we have 4 different questions and let's start with the first one. Question number 1. Decomposition of hydrogen peroxide follows the first order reaction. In 50 minutes, the concentration of hydrogen peroxide decreases from 0.5 molar to 0.125 molar in one such decomposition. When the concentration of hydrogen peroxide reaches 0.05 molar, what shall the rate of oxygen be? In order for you to answer this question, the first thing that you need to do is you need to be able to write a balance equation for the decomposition of hydrogen peroxide. So, hydrogen peroxide shall decompose to produce water and also oxygen gas. So before we can proceed, we need to make sure that these equations are balanced equation. If you can see here, in the reactant you have 2 oxygen, but here you have 3, 2 plus 1. So in order for you to balance this out, what you are going to do is times half to this oxygen. So you have 1 here plus another 1 here is equivalent to 2, which is the same as the reactant. So this is the balance equation for your decomposition of hydrogen peroxide. So what's next? What are we going to do? We need to check which order of reaction that this reaction follows. So from the question we can see that it follows the first order. Hence the formula that we can use is ln AT is equivalent to negative KT plus ln A naught. So let's see whether we have all the information that we need to plug in this formula. So we can see here we do need the initial concentration, which is 0.5, the final concentration, which is 0.125, and the time is in 50 minutes. So given to you the time is in 50 minutes. So indeed we can have most of the values that we need so that we can find the value of K. Let's plug in all this value. So ln your final concentration is 0.125 is equivalent to negative K, which is the value that we need to calculate, and the time is 15 minutes plus ln A naught, which is the initial concentration 0.5. So from there you can get negative K times 50, which is the time, is equivalent to negative 2.0794 plus 0.6931. So in saying that, we can have your negative K is equivalent to negative 1.3864 divided by 50, and therefore you will get your K is equivalent to 2.7728 times 10 to the power of negative 2. So this is the first part of the calculation. The next thing that we need to do is to write the rate expression. So rate is equivalent to whatever in the reactants must have negative. So negative delta concentration of hydrogen peroxide over delta T is equivalent to positive delta concentration of water divided by delta T equivalent to positive 2 delta concentration of oxygen over delta T. In the question, it asks you to calculate what is the rate of oxygen. So we are just going to compare between the hydrogen peroxide and also oxygen. So we are going to slash off the water over here. So I'm going to write it again. So our rate that we are looking at now is just rate is equivalent to negative delta concentration of hydrogen peroxide over delta T is equivalent to positive 2 delta concentration of oxygen over delta T. So from here, we need to move about in using the value of K that we have. So from the rate expression, you need to convert it to the rate law. Means that in the rate law, usually we have rate is equivalent to K and the concentration of the reactant itself. Right? So we are going to manipulate this one to change into the rate law instead of using it as the rate expression. Alright, now we are going to change from the rate expression to the rate law, so we can look into only the reactant instead of the product. So we are going to look into the reactant because we are going to do the rate law. Although we are going to look into the reactant, but it will reflect back what the rate of oxygen is gonna be like. So we are going to write it this way. So the rate is equivalent to K times because we are going to bring it here, so it's going to be 1 over 2 K to the concentration of the reactant. So this is your rate, so 1 over 2 times your K that you already calculated just now, so 2.7728 times 10 to the power of negative 2 times the concentration of hydrogen peroxide. So here, when the concentration of hydrogen peroxide is 0.05, so you put 0.05 over here, so you shall get the answer 1 over 2 times 1.3864 times 10 to the power of negative 3. So your rate should be equivalent to 6.9320 times 10 to the power of negative 4. So this is your rate for the oxygen. Moving on to question number 2. It took 143 seconds for 50% of a particular substance to decompose. If the initial concentration was 0.060 molar and the decomposition follows second order kinetics, determine the rate constant of the reactant. So this is rather an easy question because if you see in the question, it says that it took 143 seconds for 50% of a particular substance to decompose. So 50%, it means that this is actually the half-life. So the half-life for a second order reaction is equivalent to 1 over K times the initial concentration. So given to you is the initial concentration and you were asked to find the rate constant, which is the value of K. So the value of the half-life is 143 seconds given in the question. So 143 is equivalent to 1 over Ka times the initial concentration given to you in the question is 0.060. So from here we can say that 8.58 K is equivalent to 1. Therefore, your K is 1 over 8.58. So you will get the value of K is equivalent to 1.1655 times 10 to the power of negative 1 liter over mole per second. So this is the final answer for the second question. Let's move on to question number 3. A reaction follows zero order kinetics. The initial concentration of substance A is 1.5 molar and the concentration reduced to 0.75 molar after 120 seconds. Determine the half-life of this reaction. For you to answer this question, you need to ensure that you know what type of the kinetics that this reaction follows. So in the question, it states here is that they follow the zero order kinetic. So what is the formula for the zero order kinetic? So zero order kinetic is almost the same as the first order kinetic, only that they do not have the ln. So AT is equivalent to negative KT plus A naught. Right, so given to you is the initial concentration, the final concentration, and also the time. So from here you know that you can calculate the value of K. So the final concentration is 0.75 is equivalent to negative K, and the time taken is 120 plus your initial concentration is 1.5. So from there we can say that negative 120K is equivalent to negative 1.5 plus 0.75. So you get your K is equivalent to negative 7.5 times 10 to the power of negative 1 divided by negative 120. Therefore, you will get the value of K is equivalent to 6.25 times 10 to the power of negative 3. So this is the first part of the calculation. Right. In the question, you were asked to calculate the half-life of this reaction. So for a zero order kinetic, the half-life is equivalent to concentration of A naught, the initial concentration, divided by 2K. So you have already calculated the value of K, and you already know what is the initial concentration. So your initial concentration is 1.5 times 2. So this one, the value of K is equivalent to 6.25 times 10 to the power of negative 3. So from there you will get 1.5 divided by 1.25 times 10 to the power of negative 2. So you shall get 120 seconds. Right. So what you need to do is that you need to convert this second into minutes. So 1 minute is 60 seconds. So you should be able to know that 120 seconds is equivalent to 2 minutes. So this is the final answer for the third question. Alright, we are now at the final question for quiz 3. Question number 4. Ammonia burns in oxygen to form nitrogen oxide and water. At a particular moment, the rate at which oxygen disappears is 0.40 molar per second. What is the rate at which water is formed? In order for you to answer this question, you should be able to write the balance equation for this reaction. So in this reaction, it consists of ammonia, NH3, which burns in oxygen, O2, and will produce the nitrogen oxide, NO, plus water. So now, the easiest way for you to balance out this equation is by looking at your hydrogen in the first hand. So I'm going to put 6 here. So 6 times 2 is equivalent to 12. So at the reactant, you have 3 hydrogen here. So 1 times 3 is equivalent to 12. So it means that you need to put here 4. Since you have 4 nitrogen here, definitely you need to have 4 nitrogen at the product. So you put 4 here. So now let's calculate how much oxygen that you need. So 4 oxygen plus another 6 oxygen is equivalent to 10. So what times 2 equivalent to 10, which is 5. Next thing that we need to look at is the information given to us. The only information that you have is that you know the rate at which oxygen disappears. So it means that it's a clue for you that you need to write the rate expression. So the rate expression is equivalent to rate equivalent to negative 1 over 4 delta concentration of NH3 over delta T equivalent to negative 1 over 5 delta concentration of oxygen over delta T equivalent to 1 over 4 delta concentration of NO over delta T equivalent to 1 over 6 delta concentration of water over delta T. Alright, so from here you need to look back at the question. The question asks you which the rate at which water is formed. So it means that the important thing that we need to look at is this one, and the data given to you is oxygen disappearance, so and this one. So the rest of the thing we can just ignore for a while. So I'm just going to write it again. So rate is actually equivalent to negative 1 over 5 delta concentration of oxygen over delta T equivalent to 1 over 6 delta concentration of water over delta T. Alright, what else that you have in the question? You have the rate at which oxygens disappear. The rate at which oxygens disappear, it means that only this part. So what you are going to do is that you are going to plug in this value. So it's equivalent to 1 over 5 times 0.4 is actually equivalent to 1 over 6 delta concentration of water over delta T. So we are going to find what is this value first, then only we will work things out. What I'm going to do now is I'm just going to rearrange it so that it's easier for us to see. So 1 over 6 delta concentration of water over delta T is equivalent to 1 over 5 delta concentration of oxygen over delta T. It's just the same. I'm just going to rearrange it. So right, because this one is the reactant. Alright, so what you need to do is now, because it says that the rate at which oxygen disappear is only for this part, right? So we can say 1 over 5. I'm not going to look upon the negative and positive because it's just the positioning of the reactant and the product. So here times 0.4, so it's equivalent to 8.0 times 10 to the power of negative 2. Right, so you were asked to calculate what is the rate at which water is formed. So 1 over 6 delta H2O over delta T is actually equivalent to 8 times 10 to the power of negative 2. But you want only this part. So you're going to bring this up. So delta concentration of water over delta T is actually equivalent to 8 times 10 to the power of negative 2 times 6. So you shall get equivalent to 0.48 molar per second. Right, this is the final answer for the fourth question. Alright, so this is the end of the video for this week. I really hope that this video will help you to understand more on chapter 3. So I'll see you again next week. Take care, be good. Goodbye.